Okay, here's the big change from what you were taught before. And that is where the electrons are actually thought to be placed. So up to this point, we dealt with levels, and we talked about spheres and which the levels encompass. But there are things going on within those levels that we have to look at as well. And how many electrons go into those areas within the level that we call orbitals. Orbitals are paths where the electrons are traveling. And every level has a certain number of orbitals or paths that they are allowed to have. And it depends upon size and number of things as well. So, up to this point, we have the principal quantum number n equals 1, 2, 3, 4, and so on. And this is what we pretty much talked about. We said that this is n equals 1 right here. This is n equals 2. And then this is n equals 3. And n equals 4. And it keeps going on, all the way up to infinity, which means the electron has been pulled completely out of the atom, which happens a lot. So n is 1, 2, 3, 4, and so on, all the way up to infinity if the option takes place. But what happens inside these levels? And that's the new thing. Now this is called the principal quantum number. There are 4 quantum numbers. This is the first one, and this drives what happens with all the others. The second one is called the secondary quantum number. Now the secondary quantum number is also called the angular momentum or the azimuthal quantum number, but basically it describes the shape of which the orbital is going to be within a particular level. And those are represented by numbers as well. And it turns out the lowest possible number for L is 0. And the next one is 1 and 2 and 3 and so on, all the way up to, now the biggest one it can be is 1 less than whatever this number is right here. Not infinity. Now technically infinity is a number that is beyond what we can deal with. And so I guess the highest number is infinity minus 1, but what is infinity minus 1? I don't know. So we just say n minus, not n equals 1. N minus 1. All the way up to n minus 1. So what that means is this. If we're on level 3, that means n equals 3. So this right here, n equals 3. And then we can have values of L equals 0, 1, and 2. 2 is the maximum value. So any one of these 3 descriptions of shapes of paths can exist in level 3. In level 2, that means then, of course, that n equals 2, and that means the value of L equals 0 and 1 only. And then, of course, level 1 then means that n equals 1, and then L can only equal 0. Now, this tells us a lot right here. Now, this is all coming from the quantum theory. These are just like little snippets of what takes place. This is just a very oversimplification of that, but it gives us a chance to understand why the electrons are thought to be placed where they are. When L equals 0, that means it is describing a shaped path that exists only in level, the only one in level 1. Well, what's happening in level 1? It's a sphere. Now, this is a 3-dimensional representation. I only have 2 dimensions here, but there's one coming straight out of the board. That's the z-axis, the one going behind. And the nucleus is right here at the intersection of all 3 axes. You see that there's only a sphere. That's all it can be. So that means then, when L equals 0, that it's traveling in a sphere. Okay? Now, so let's get back to the discussion we have here. Oops, wrong one. So, next quantum number is L, as I described there, and it describes the mathematical probabilities of uncertainty, because we're never really 100% sure where those electrons are found. But we know that if n equals 3, the highest value of L is 2. Each value of L actually represents the shape of the orbital most likely taken by an electron. And the lowest value is 0. And that is the spherical orbital. Now, here's the big thing here. Chemists designate electrons that travel in a spherical orbital as s electrons. Okay? And it turns out that every level starts with a spherical orbital path, because they all start at 0 for L, which means that every level starts with 2s electrons, meaning that there are 2 electrons in each path. Every orbital has 2 electrons in it. So we take a look at row 3 in the third sphere. We'll get to that in just a minute here. That means then that row 3 we have potassium and calcium. Sodium and magnesium. And that means then that the last electron, the highest energy electron, is found in the S's, in the spheres. Okay? So, what that is saying then is that here we have 2 electrons here in the first sphere. We have 2 electrons in the second sphere, and we have 2 electrons in the third sphere. The highest energy electrons for all those elements that are found in those first 2 columns on the left-hand side. So we call these 1s electrons, we call these 2s electrons, we call these 3s electrons. Okay? All right. So let's get back to what we've got here. Okay? So the next thing we have is when L equals 1. Now, that only happens starting in the second level. Why? Well, as we just showed just a little bit ago, when L equals 2, that means N equals 2, the possible values for L are 0 and 1. The lowest energy of the 2 is the 0 one. That represents a sphere. Level 1, and L value of 1, secondary quantum number value of 1, means it's a different shape from the sphere. And it turns out that these are called three-dimensional figure 8 paths, or orbitals. They look like dumbbells, like when you work out, kind of the same shape as a dumbbell. They have higher energy. It takes the highest energy electrons are found in the three-dimensional figure 8 as opposed to the sphere. So if we take a look at that second level, now we have, and I'll kind of generally draw what it looks like here, but you have a three-dimensional figure 8 the size of that sphere. So it looks something like this. And then if we imagine the z-axis coming out here and coming behind here, the board, then this would be on the out, coming straight out at you and going behind the same size as these 2 right here. And there's 2 electrons in every path. So since there's 2 electrons in every path, how many electrons are we talking about? 6. 3 paths, 2 electrons in each. Those are called p electrons. So these are p electrons. 0 is called s electrons. And these are on the second level, so these are all 2p electrons. All right? This is 1s for the 2 here, 2s for all the sphere here, and 2p's second level p's for the next higher energy electrons. So that means all these elements here on the second level, boron through neon, fit that. If we did the same thing with, and I'll put this in blue so you can distinguish them here. There we go. I don't like it when that happens. Okay. We got this. We got this. And then we have it's coming out and going behind the board. I don't know why he's doing this. Stop it. Okay, and there are electrons on each one. So we have 1, 2, 3, 4, 5, and 6 electrons.